Hello. In my last video, I proved what happens if we combine the same transformations, such that if I did a stretch and followed by a stretch, I still got a stretch, and that the scale factors were multiplied together. That if I had a rotation and another rotation, well, still had a rotation, and the angles were combined together to be θ1 plus θ2. The weird one, you could say, is a reflection and a reflection resulted in a rotation, and we had the difference of the angles doubled, and quite often you see that written in modulus. What we're going to do in this video is start thinking about what happens when I get a reflection and a rotation. I do it in different orders. What am I going to get? Okay, here we go. So I'm going to apply reflection through angle phi and a rotation through angle theta. And I'm going to be applying the reflection first, so that'll be on the right hand side because I'm working right to left. Multiply it out. So here we go. Let's work out what's happening in this. So let's start with top left. So I've got a cos times a cos, and I've got a sine times a sine, but I've got a negative sign there, haven't I? Which you know from your compound angles is going to be the cos of those two angles added together. Good. What's happening in the bottom right corner? Well, here I've got a sine times a sine, that's the positive, and I've got a cos times a negative cos. So I've got the same expression, but the sign's changed, isn't it? So if I want to use the same angle inside, 2 phi plus a theta, I've got a negative sign out the front. Okay, so they both turned out to be coses. What's happening in the other corners, top right and bottom left? Let's have a quick look. So top right, well, I've got that cos times that sine, and I've got that sine times that cos, which are both negative. So what have I ended up with? I've ended up with a cos sine plus a sine cos. Well, we know that that's the addition. If this is a positive here, we know from our compound angles that we're adding the two angles inside there. So I'm getting the sine of 2 phi plus theta. And if I go and look in the bottom left, I get the same setup because I've got a sine times a cos, and then I've got a cos times a sine. All of those are positive, so I get exactly the same expression there. So these two are the same. Okay, so what does this all mean for me? Let's have a look at what I've got down here in the bottom. Is my final final matrix. So all of them have got the same angle inside, 2 phi plus theta. Now I need to know whether it's a rotation or a reflection. So I go looking for the negative sign, and the negative sign is in the bottom right. That tells me this is a reflection matrix. And if it's a reflection matrix, I just need to remember that what's the angle it's reflecting through is where I just need to halve whatever's inside. So I'm going to get phi plus a half of theta over 2. So that's what I get if I do my reflection and then my rotation. Okay, let's have a look at what happens if I do them the other way round. So I'm going to do my rotation first and then my reflection. And so these will appear the other way round in my calculation. Of course, I'm working right to left again. What do I get in my top left corner? Well, I've got a cos cos and a sine sine. So here it is. That's got a positive sign, it's positive here. So what does that tell me? For my compound angles, I know that I'm looking at the difference here. And I'm going to write it this way round as 2 phi minus theta, but it's the difference in the two angles. Okay, what's happening in the bottom right corner? Because it always fits together with this top left. So I've got a sine sine, but that's negative, and I've got a cos cos, but that's negative. And you'll see I've got the same expression, except the sign is different, isn't it? So I've got the same, so what's the word I'm looking for? Same angle inside. It's the difference of two angles. The only difference is I've got a sign change, haven't I? It's a negative cos here. Okay, so that was that. Now let's look at top right and bottom left and what's going on with those and see what happens to those. Well, top right is cos negative sine, and then sine cos is positive, so I get this expression here. And if I look at the bottom left, I've got that sine cos, and I've got a negative cos sine, which is this one here. Now you might have noticed that these are the same expressions, and usually we would be thinking of this as the positive bit first and the negative there. And so we're looking at a difference of two angles, and usually that will be the bit at the front, wouldn't it? Because it's sine cos, take away cos sine. So I'm going to have my difference and the same difference angle inside there, but they're both sines, aren't they? A sine of the difference of two angles. So now I'm looking at that. I've got the same angle inside each of my trig functions, and so I know that that's the angle that's applied. But what do I need to do to know whether it's a rotation or reflection? I have to look where the negative sign is, and the negative sign is in the bottom right. And if the negative sign's in the bottom right, it's a reflection. And if it's a reflection and I want to know the angle of that, I have to halve whatever's inside the bracket. So here I've got phi, and then I've got subtract theta over 2. So there we have it. Let's have a look. So if I'm using these different combinations, then a reflection followed by a rotation is going to also be a reflection, and the angle it's going through is the reflection angle plus half of the rotation angle. And if I do it the other way around, I've got the rotation first, then the reflection, then I also end up with a reflection, but the angle this time is the reflection angle subtract the rotation angle halved. So a bit of a weird one. Don't expect you to remember it necessarily. You could, but if not, you can work it out using what we've just done. Best of luck.